let vector u of t be equal to 7t cubed I hat plus t squared minus 9j hat minus 4k hat. And we're asked here to compute the derivative of the following function. We have vector u of t to the fourth minus 2t. So in order to differentiate this, we're going to need to apply the chain rule. So let's just start by thinking about what we need to do. So we are given that vector u of t is defined as 7t cubed I hat plus t squared minus 9j hat minus 4k hat. So if this is our original vector valued function, then we know that the vector valued function u of t to the fourth minus 2t is going to be the same function, except each one of the t's in the original function will be replaced with t to the fourth minus 2t. So what does this leave us with? Well, we're left with 7 multiplied by t to the fourth minus 2t cubed I hat plus we have t to the fourth minus 2t squared minus 9j hat minus 4k hat. All right, so this is the vector valued function that we want to differentiate. So here we go. Let's go for it this time. So we want to differentiate with respect to t. And I'll abbreviate with respect to t, our arbitrary parameter. So here we go. We have vector u prime of t to the fourth minus 2t is equal to, and because this looks like it's going to have a pretty large derivative, I'm going to start on the line below. So differentiating our first component here, our f of t component, we are left with, so 7 times 3 leaves us with 21 multiplied by t to the fourth minus 2t, and this is squared, multiplied by the derivative of the inside. So that's 4t cubed minus 2 multiplied by I hat plus, so now we have the derivative of our g of t component. So this is going to be 2, hold your inside constant, so t to the fourth minus 2t to the first, multiplied by the derivative of the inside. So again, that's 4t cubed minus 2j hat. And now, when we differentiate the h of t component, that's just a constant. So it goes to 0. And we don't even need to include that part. So what's our beautiful final answer? Well, therefore, vector u of t to the fourth minus 2t leaves us with the unsimplified answer. We can write this as 21 multiplied by t to the fourth minus 2t multiplied by 4t cubed minus 2. And our second component is 2 multiplied by t to the fourth minus 2t multiplied by 4t cubed minus 2. And then our last component here is 0. So this is our final answer. There's nothing wrong with this answer, with the exception of the fact that it's unsimplified. So what is your greatest common factor here? What could we pull out of each component? And also, shame on me, I dropped my 2 minus 1 on my test. Make sure, note here in the derivative of our first component, that is squared. So with that in mind, what can you pull out now? Well, we have a greatest common factor of t to the fourth minus 2t multiplied by 4t cubed minus 2. So an alternative way to write our derivative here would be t to the fourth minus 2t multiplied by 4t cubed minus 2. So that is your scalar multiple multiplied by the vector 21 times t to the fourth minus 2t to 0. And so this is our beautiful final answer here. Both forms are correct. It just depends on which format you're being asked to leave your answer in.